we want to solve the trig equation 2 cosine squared x minus cotangent x equals 0 over the given interval. We will use the strategy of converting to sines and cosines, and therefore we'll substitute cosine x divided by sine x for cotangent x. This gives us 2 cosine squared x minus cosine x divided by sine x equals 0. And because we have a fraction here, let's write 2 cosine squared x as a fraction with a denominator of 1. In order to subtract the fractions, we know we must have a common denominator, which in this case is sine x. So for the next step, we will multiply the numerator and denominator of this first fraction by sine x. This gives us 2 cosine squared x times sine x all over 1 times sine x. And we still have minus cosine x over sine x. But notice now we do have a common denominator of sine x, and therefore we can subtract these fractions. The denominator is going to remain sine x, and the numerator is now 2 cosine squared x sine x minus cosine x. And this is still equal to 0. Notice how we have a fraction equal to 0. A fraction is equal to 0 when the numerator is equal to 0 and the denominator is non-zero, which means the fraction on the left is equal to 0 when the numerator of 2 cosine squared x sine x minus cosine x is equal to 0, and also the denominator of sine x can't equal 0. Sine x can't equal 0 because if it did, we would have division by 0. We could have also gotten the same result by clearing the fraction from the equation by multiplying both sides of the equation by sine x. And now to solve this equation here, the next step is to factor out the greatest common factor, which is cosine x. Factoring out cosine x gives us cosine x times the quantity 2 cosine x sine x minus 1 equals 0. Let's continue on the next slide. Notice how we have a product on the left, and therefore the product is equal to 0 when the first factor of cosine x equals 0, or when the second factor of 2 cosine x sine x minus 1 equals 0. But looking at the second equation, notice how we have 2 trig functions here, and therefore we have to perform another substitution using the double angle identities shown here on the right. Notice 2 sine theta cosine theta is equal to sine 2 theta, and therefore 2 cosine x sine x is equal to sine 2x. Performing the substitution gives us sine 2x minus 1 equals 0. Solving for sine 2x, we add 1 to both sides, which gives us sine 2x equals 1. So notice here we have cosine x equals 0. Here we have sine 2x equals 1. Because we have a double angle here, we'll perform another substitution and let t, another variable, equal 2x. So notice now we have cosine x equals 0 or sine 2x equals 1. Because we have a double angle here, we'll perform another substitution and let the variable t equal 2x. So if t equals 2x, we will solve the equation sine t equals 1. But we need to be careful here because if t is equal to 2x and x is on the interval from 0 to 2 pi, 2x is on the interval from 0 to 4 pi, and therefore so is t. So we'll have to solve t over the interval from 0 to 4 pi, and then come back and find x. Notice if t is equal to 2x, if we multiply both sides by 1/2, x is equal to 1/2 t. So let's go to the unit circle and find our angles. Let's first solve the equation cosine x equals 0. Remember, on the unit circle, x equals cosine theta and y equals sine theta, which means to solve the equation cosine x equals 0, we are looking for the point on the unit circle where the x coordinate is 0. And these points occur on the y-axis here as well as here, which means one solution for x is x equals pi over 2 radians, or 1/2 pi radians. Another solution is 3/2 pi radians. So again, these are solutions for x, which we are solving the equation for. And now let's solve sine t equals 1. Remember though, because t is equal to 2x, and 2x would be the interval from 0 to 4 pi, we need to solve this equation for t from 0 to 4 pi radians. To solve sine t equals 1, we look for y-coordinates of the unit circle that are equal to 1, which only occurs in one place, which is here. So one solution for t, remember this is t not x, is pi over 2 radians, or 1/2 pi radians. So let's go ahead and record this. T equals 1/2 pi. Remember, we're solving on the interval from 0 to 4 pi radians. So another angle in the interval that's coterminal to 1/2 pi radians would be this angle here. One complete revolution past 1/2 pi radians, which is 1/2 pi plus 2 pi, which is 5/2 pi radians. So t can also equal 5/2 pi radians. But we're not done here. We now need to find x, where x is equal to 1/2 times t. So using t equals 1/2 pi, we would have x equals 1/2 times 1/2 pi, which is 1/4 pi. And then when t equals 5/2 pi, x is equal to 1/2 times 5/2 pi, which gives us 5/4 pi. So notice how the solutions in terms of x are on the interval from 0 to 2 pi radians. We have a total of 4 solutions. We have x equals 1/2 pi, x equals 3/2 pi, x equals 1/4 pi, and x equals 5/4 pi. I hope you found this helpful.